next lecture is related to the steam generation unit. See, in the previous lectures we discussed about the different concept of steam, what is the basic philosophy for steam generation. We discussed about the various aspects of the boiler, concept of boiler, what are the integral part of the boiler, all these things we have discussed in the previous lectures. Now, in this particular concept, first we will discuss about the various components of a steam generation unit. Then we will discuss about the furnaces, because the furnaces are integral part of any steam generation aspect. Since we require fuel and the coal is having a significant portion among all the choices of fuel, then we will discuss about the pulverized coal system and draft system. So, let us talk about the steam generation unit. See, previously we discussed about the boiler, different parts of the boiler, integral part of the boiler, classification of the boiler, definition of the boiler, all these things. Now, alone boiler can't produce steam. So, for this you require various other allied parts, accessories, different units, like we discussed that fuel cannot be used as such, especially coal, because the coal usually raw coal comes in the form of lump and other things. So, you need to go for fuel preparation. Thereafter, you need to go for some other allied functions before this fuel or water, they can come and become the part and parcel of steam generation aspect. Now, since this steam generation is based on the combustion of fuel, so you cannot overlook the importance of various type of environmental protection activities, because the flue gases, they not only carry the harmful gases, but also significant quantity of heat. So, all these things, they usually contributes towards the basic definition of steam generation, and every unit has its own importance. So, that is why when we talk about the steam generation unit, the key subsystems, they includes the fuel receiving and preparation. You may receive either, it may be fuel may be the natural gas, or fuel may be the oil, or fuel may be coal. Then different accessories and mountings apart from the boiler contributes among the concept of steam generator, combustion. Then we must look into the environmental aspect, the turbine generators, heat rejection aspect, cooling towers, because sometimes you need to perform the heat recovery as well as you need to go for the condensation and other channeling aspects. So, for this the cooling tower plays a very vital role. Now, here you see the different part of turbine generation heat rejection system. Here you see that the fuel is being received at the fuel receiving station, that is here we are taking the example of a coal. So, coal supply, then go for the coal dressing, so that it can be used as a fuel to the boiler system. Similarly, the environmental protection and environmental aspect, here you are having boiler, because as I told you that it is a combustion reaction. Here you need adequate supply of air within stipulated quantity and a flow rate. So, you are having the combustion air with the help of a forced draft fan air heater, it goes into the boiler. But when we perform the combustion reaction, then obviously there are two integral parts. One is the heat and second one is the various off gases. Apart from this, we are having some unburned coal. So, that is why you are having various particulate collectors, then scrubbing units, and whatever left, it goes to the atmosphere through the various treatment methodology. And another thing is that once you produce the steam, then there are turbine generators, because if you produce the steam, then obviously you will utilize this steam somewhere. Now, here we are taking the example of a steam generator. Apart from this, steam can be used as a sparging steam, it can be used as a slurry preparation methods, it can be used for the mixing, etc. So here is steam generator or heating purpose. So here is steam generator, and see, there are two, three different part. One is that you are producing the power. Second is that by in this way you may produce some water may get condensed. So you may have some condensate recovery lines, because again I told you that water is a precious one. Then you are having the cooling tower and makeup pumps. So all these some of the integral part of entire steam generation unit. So let's take one by one, because see, if you follow the fuel and a product of combustion through the system, the fuel handling system usually stores the fuel supply, that is coal for this particular example. This prepare the fuel for combustion and transport it to the steam generation. As you know that we require some specific size in terms of coal. So you can go for say pulverization, grinding, etc. Whatever required for this one, that is the attributed to the fuel receiving and preparation section. When you have selected the fuel, you have dressed the fuel as per the requirement, then the next aspect is the combustion air, because it's a combustion reaction and you need to supply the air by utilizing the fact that it contains 21% of oxygen. So the associated air system usually supplies air to the burner through a forced draft fan here. Now the steam generator subsystem, this includes the air heater, because normally if you supply the normal air or atmospheric air, then definitely the efficiency of the boiler would be on the lower side, because the atmospheric air is roughly available at say 25 to 30 degrees Celsius. So you need to have some air heaters so that the temperature difference can be minimized. Then this here heater burns the fuel air mixture to recover the heat. Sometimes it may be the source of heat to the air heater may be unutilized heat from the various processes. Then the generators, those who are controlled high pressure and high temperature steam. So all these air contributes to this boiler subsystem. Now next aspect is again very crucial, especially in the present day scenario, that because if we are having the combustion, then obviously the combustible air or flue gas may contain various things like unburnt fuel. It may have some undesired gases, etc. So the flue gases, those leaves from the steam generator subsystem, or sometimes you may have selective catalytic reduction system, if supplied, then pass through a particular collection and sulfur dioxide scrubbing system. Because see, in coal, apart from carbon, there may be a chance that significant quantity of sulfur may present. Since we are performing the combustion reaction, so a certain quantity of SOx may get generated over the period of time, and you cannot discharge this SOx to the atmosphere as such. Therefore, you must have some scrubbing unit to remove these SO2 or SO3 being formed in due course of time. So there are scrubbing units and you can remove the sulfur in a scrubber residues form over the period of time. And there is a stick which discharges the remaining flue gas either through the induced draft fan or sometimes it may be through the natural draft. Now another thing which is very important, that is the steam water path, because we are generating steam and steam obviously being utilized to somewhere in some process utilities. So the steam generator, that is boiler, here this one, this boils water and creates a steam at a high pressure. So under the carefully controlled condition, which is essentially required for the boiler operation, and it is sent to the turbine generator to produce the electricity or work whatever required. Now this steam may also be reheated in a steam generator after passing through the part of multi-stage turbine system by running the exhaust steam back to the boiler convection pass. Apart from this, you may utilize the whatever condensate being formed as a source of feed water, and because sometimes this condensate is available uh, at a substantially high temperature. So, it always enhances the boiler efficiency if we use as such. Now see, when we are talking about the steam, this may also be reheated in the steam generator, and if we pass through the multiple stage turbine system, we can extract the work. Now here you see that we are having these preheaters, superheaters, etc. for the maximization of boiler efficiency. Now theoretically, the addition of one stage reheater utilization, this increases the thermal efficiency of Rankine cycle by 3 to 4%. Now the addition of two stage of the reheater, it normally increases the efficiency say by 1.5 to 2%. So, and the addition of three stage reheater increases the efficiency by 0.75 to 1% and so on. So commonly the modern boiler, they only uses one or two stage reheating system. Now ultimately the steam is passed from the turbine to the condenser, where the remaining waste heat is rejected. Now before the water from the condenser is returned to the boiler, it passes through the several pumps and heat exchangers, that is obviously the feed water heaters, to increase the pressure and temperature. Now heat absorbed by the condenser is eventually rejected to the atmosphere by one or more cooling tower. So here this is the cooling tower. So whatever heat being absorbed, it is rejected to the atmosphere, but in a very controlled manner. Now here see the cooling tower, again the cooling tower is very, you can say, important or integral part of any steam generation segment. So there may be a natural type of or a forced type of a cooling tower. So the natural draft cooling tower, which is shown here, is basically a hollow cylinder. You see that this is a hollow cylinder which circulates air and moisture to absorb the heat rejected by the condenser. Now here you see that the hot water supply, and this draft eliminate the water distribution. So and here you are passing to the air, and from the bottom part of this, the cooled water is being discharged and it can be reused to the steam generation unit. Now such cooling tower exists in most modern power plant site, maybe nuclear or maybe the fossil fuel fired. In nuclear power system, the fossil fuel fired steam generator is replaced by the nuclear reactor vessel, and typically two or more steam generators. This is the only you can say the supplement thing in the nuclear fired reactors. The coal handling system is replaced by the nuclear reactor fuel bundle handling and storage facilities, and the large scale pollution control equipment is not needed. Here you can see that previously when we were discussing about the steam boiler fired steam generation plant, here this is being replaced with nuclear reactor. Now here you see that this is your nuclear reactor through which you are generating the heat for the production of steam. So here this is a steam generator and this is the reactor from which you are generating the heat to produce the steam over here. Now since the chances of any pollution or especially the atmospheric pollution are negligible, so the stake and other particulate unit or has been replaced or removed from this particular juncture. So this is the basic difference between the nuclear reactor steam generation unit and boiler type of steam generation unit. Now let us talk about the major components. The major component in the steam generating and heat recovery system, they are including furnace and convection pass, steam superheaters, maybe primary and secondary, steam reheaters, boiler or steam generating banks, economizer, steam drums, a temperature and steam temperature control system, air heaters. Let's talk about the furnaces, because furnace is the core of any boiler or steam generation unit. So there are various types and the classes of furnaces. One is based on the method of generating heat. So in this category, the furnaces are broadly classified in two types, mainly combustion type, those who are using the fossil fuels, and second one is the electric type. Now, in the case of combustion type furnace, depending upon the kind of combustion, it can be broadly classified into oil fire, that is the liquid phase, coal fire, that is the solid phase, and the gas fire, that is the gaseous phase. Another classification may be based on the mode of charging of material. These furnaces can be classified into intermittent or batch type furnace or periodical furnace and continuous furnace, sometimes based on the mode of waste heat recovery. One is the recuperative and second one is the regenerative furnace. Another type of furnace classification is made based on the mode of heat transfer, mode of charging and mode of heat recovery. So, here you see that the furnace classification is based on heat transfer. One is based on the open fireplace and second one is the heated through medium. Another classification, batch or continuous, then recuperative and regenerative. Further, this particular classification is subclassified into the re-rolling type of pushers, pot, forging, and recuperative and regenerative type glass tank melting continuous operations. Now, the furnace should be designed in such a way so that in a given time, as much of as material which is possible can be heated to a uniform temperature as possible with the least possible fuel and labor. That is essential for the economics of the boiler or steam generation unit. Now, question arises that how to achieve this. So, to achieve this, there are certain parameters need to be considered. One is that determination of the quantity of heat to be imparted to the material or charge, that depends on the steam requirement, that depends on the other parameters, that how much temperature you require, what is the pressure you require. So, all these things are interlinked. Then another parameter which need to be considered is the liberation of sufficient heat within the surface to heat the stock and overcome all heat losses. Another part is that the transfer of available part of that particular heat from the furnace to the surface of the heating stock. So, any kind of lagging is always undesirable. Then equalization of a temperature within the stock is another consideration, and the reduction of heat losses from the furnace to the minimum possible extent. See, there are various approaches and there are three basic modes of heat transfer from the furnace, that is conduction, convection and radiation. So, these furnaces must be designed in such a way to reduce any kind of heat loss attributed to these modes of heat transfer. Now, let us talk about the pulverized coal system. We have already discussed the concept of pulverization in the previous lectures. So, pulverized coal firing is usually done by two systems. One is the direct system or called as a unit system. Second is the central system or bin type of a system. Now, in unit system, the raw coal from the coal bunker drops into the feeder. That is this is the raw coal banker, and it is the feeder, and then this is the pulverizing mill, and through this it goes to the desired station. Now, usually the hot air is passed through the coil in the feeder to dry the coal. Sometimes some moisture or sometimes because of the mining issues, this may be wet during the use. Now the coal is then transferred to the pulverizing mill. Here you see that this is the pulverizing mill where it is pulverized, and in between you need to supply the primary air to the mill by the fan. Here you can see that ID fan is supplying the primary air. Now the mixture of pulverized coal and primary air is then flow to the burner where secondary air is added. Now here you see that this is transported to the burner. Now the unit system is so called from the fact that each burner or burner group and pulverizer constitutes a unit. So you can say this is entire a unit. Now there are various advantages attributed to this type of system. The system is simple, then the central system, the direct control of combustion from the pulverizing mill. Now the coal transportation system is extremely simple. Now let us talk about the bin or central system. Here the crushed coal from the raw coal bunker is fed by gravity to a dryer where hot air is passed through the coal to dry it. Dryer may use waste flue gas, preheat air or a bleeder steam as a drying agent. This dry coal is then transferred to the pulverizing mill, and the pulverized coal obtained is transferred to the pulverized coal bunker, that is called as bin. The transporting air is separated from the coal in a cyclone separator. Now here you see that this is the raw coal bunker dryer, and this is the pulverizing mill, and through this it is conveyed to the desired station. And here you see that we are having the primary fan, and this pulverized coal burner, it is subjected to the furnace. Now here you are mixing the primary air in the system so that it can have combustion properly. There are again various advantages attributed to this central system. The pulverizing mill grinds the coal at a steady rate irrespective of boiler feed. There is always some coal in reserve, thus any occasional breakdown in the coal supply will certainly not affect the coal feed to the burner. And sometimes it is quite common that because it is being transported through the rail system, etc., and any kind of disruption in the coal supply sometimes may cause a problem to the regular steam generation. For a given boiler capacity, pulverizing mill of a small capacity may be required as compared to the unit system. So these are the advantages. But when there are advantages, then of course there are certain disadvantages too. One of the disadvantages is that the initial cost of system is high. You see there are various units associated with this one. It is not a single unit. So the initial cost of system is high. So initially you may experience that cost of your steam generation is, or per unit cost of the steam generation is on the higher side. Then the coal transportation system is again very complicated, and you see that in the figure that this system requires more and more space. So ultimately when we talk about the other aspects or plant in totality, this again contributes a lot of economics. Let us talk about the performance. To a large extent, the performance of pulverized fuel system depends upon the mill performance. Now the pulverized mill should satisfy the different requirements. One is that it should deliver the rated tonnage of coal. Obviously it is one of the foremost requirement, and the pulverized coal produced by it should be have satisfactory fineness over a wide range of capacities. So you must have desired fineness or desired particle size before it goes to the furnace. Apart from this, it should be quiet in operation. because sometimes noise may create a problem, and the power consumption, it consumes significant quantity of power, so its power consumption should be low, and maintenance cost of the mill also should be very low, so that the per unit cost of steam can be reduced substantially. For this, you may require certain equipment, especially both for unit as well as a central system of a pulverized coal handling plant. For raw coal, you require the primary crusher because it usually forms in the very big sized lump. Then magnetic separators, because some sort of metal, especially iron impurities, can be removed a priori. You must have a coal dryer. We have already discussed that it contains significant quantity of water as well as moisture. So, before it goes to the either pulverization or furnace, it should be dried. Must require the coal bunkers. Now, here you see for the coal bunkers, both for the unit system and central system. Now, here your unit system, you need the scale, then the pulverization, different units, and it goes to the burner, and you may have different burners. Here in the central system, you must have a scale, then perform the pulverization operation, goes to central bin, feeder, and through feeder it goes to the different furnaces through burner. Now, let us talk about the draft system. Now, most boiler, they are now depend on the mechanical draft equipment rather than the natural draft, so that easily and free movement of this draft can be possible. Now, this is one of the reason in more scientific way is that natural draft is subjected to the outside air conditions, temperature of the flue gases, leaving the furnace as well as the chimney height. So, the chimney height, temperature, as well as apart from this the composition of flue gases, all these are the contributing factor towards the natural draft. Now, all these factors, this make the proper draft extremely hard to attain, and therefore make mechanical draft equipment much more economical. Usually we are having three different type of mechanical draft. One is the induced draft, second is the forced draft, and third one is the balanced draft. Now, induced draft, this is obtained one of the three ways, and the first being is that the stake effect or a heated chimney, in which the flue gas is which is less dense, because at the higher temperature there is less dense than the ambient air surrounding the boiler. Now, the denser column of ambient air forces the combustion air into and through the boiler. The second method is through use of a steam jet, etc. Usually the steam jet oriented in the direction of the flue gas flow induce the flue gas into the stake and allows for a greater flue gas velocity, increasing the overall draft in furnace. Now, this method was common on steam driven locomotives which could not have a tall chimney, because the tall chimney they can't afford. During the movement it may create a problem. Now, the third method is by simply using an induced draft fan, and referred as ID fan, which removes the flue gases from the furnace and force the exhaust gas up to the stake. Almost all induced draft furnace operate with a slightly negative pressure. Let us talk about the forced draft. Now, this draft is obtained by forcing air into the furnace by means of forced draft fan and ductwork. Air is often passed through an air heater, which as the name it suggests, that heats the air going to the furnace in order to increase the overall efficiency of the boiler. Sometimes dampers are used to control the quantity of air admitted to the furnace, and forced draft furnace usually have a positive pressure. Next is balanced draft. Balanced draft is obtained through use of both induced and forced draft. This is more common with the larger boilers where the flue gas have to travel a long distance through many boiler passes. The induced draft fan usually works in conjunction with the forced draft fan along with the furnace pressure to maintain slightly below atmospheric. Now, in this particular chapter or lecture, we discussed about the various parts of steam generation unit, especially the fuel, then stake, then steam burners, etc. And we discussed various integral parts which are attributing towards the proper steam generation unit segments. For your convenience, we have enlisted 4 references. If you wish to have more studies or more knowledge, then you can go through all these references. Thank you very much.